Ever wondered what a black start of the power grid is? Well, let's set the stage for this riveting exploration. Picture this: a massive, intricately connected network, pulsing with electricity. That's a power grid, the lifeblood of our modern society. From illuminating our homes to powering industries, it keeps our world humming 24 hours a day, 7 days a week. Now imagine the pulse stops, the lights go out, the machine stands still. That's a blackout, a sudden widespread power loss. It's more than just a minor inconvenience. It disrupts lives, halts businesses, and can even pose significant safety risks. So, what happens when a blackout occurs? How do we jumpstart this massive electrical network? Enter the intriguing concept of a black start. It's like a defibrillator for the power grid, bringing it back to life after a blackout. Now that we have established what a power grid is and how crucial it is, let's dive into the concept of a black start. In the world of power grids, a black start isn't as ominous as it sounds. This term might evoke images of a dystopian world shrouded in darkness, but in reality, it's a crucial part of our power systems that helps keep the lights on. So, what exactly is a black start? In the simplest terms, it's the process of restoring an electric power station or a part of an electric grid to operation without relying on the external electric power transmission network. Imagine your house's circuit breaker trips, plunging the entire place into darkness. You'd naturally go to the breaker box and flip the switch back on, restoring power. That's a very simplified version of a black start. In the case of a power grid, the stakes are much higher. If a grid goes down, it can affect entire cities or even countries, leaving millions without electricity. To prevent this, power grids are designed with black start capabilities. The process of a black start is complex and requires careful coordination. It begins with identifying power stations that have black start capability. These are usually hydroelectric power stations or gas turbine plants that can start up using their own internal energy sources without needing power from the grid. Once these power stations are up and running, they start to supply power to the rest of the grid in a controlled manner. This is done in stages, starting with critical infrastructure like hospitals and emergency services, then gradually extending to other parts of the grid. A black start is not just a technical process, but also a strategic one. It requires detailed planning and coordination between different stakeholders, like power companies, grid operators, and regulatory authorities. Why is a black start necessary, you ask? Well, it's a bit like an insurance policy. We hope we never have to use it, but in case of a major power outage, it's a lifesaver. It ensures that power can be restored quickly, minimizing disruptions and preventing potential chaos. So, a black start is essentially the power grid's self-recovery mechanism. It's a fail-safe that ensures we can always flip the switch back on, no matter what. Now that we understand what a black start is, we can delve deeper into the process. Picture this. The first stage of a black start is akin to a small ember in a fireplace, which will soon spread its warmth throughout the house. In the context of a black start, this ember is a small set of power stations equipped with black start generators. These generators are essentially the spark plugs of the power grid. They don't require external electricity to start up and can thus serve as the initial source of power to get the grid back on track. Our ember, the black start generator, now begins to fan its flames, which in our scenario means it starts to supply power to a small part of the grid. This is the first step in the black start process. It's like a heart beginning to beat, pumping life into what was a lifeless system. Next, we move on to the second stage. It's as if the ember is now caught onto a log, growing larger, brighter. Similarly, the black start generator begins to supply power to larger parts of the grid, progressively adding more power stations. This stage is critical because it involves synchronizing the frequency and phase of the different power stations, ensuring they work in harmony. And finally, we reach the third stage of the black start process. Like the fire now roaring in the fireplace, spreading its warmth throughout the house, the black start generators have managed to restore power to the entire grid. It's a systematic process, almost like a carefully choreographed dance, where every move counts, and one misstep can throw the whole sequence out of balance. But when done right, the result is a fully functional powered grid, rising from the ashes of a blackout, ready to serve its purpose once more. It's a testament to the resilience of our power systems and the ingenuity of the engineers who keep them running. The black start process, therefore, can be seen as a chain reaction, starting small and gradually powering the entire grid. It's clear that the black start process is vital, but why exactly is it so important, and what challenges does it pose? The importance of a black start can't be overstated. Imagine a power grid as a vast interconnected web of power plants, transmission lines, and consumers. Now imagine that web plunging into darkness. That's a blackout. Without the black start capability, the power grid could remain in this state of darkness indefinitely, causing severe disruptions to our daily lives, economies, and essential services. A black start is the emergency response team of the power grid swooping in to breathe life back into the grid. It's the first step in the recovery process. After a total or partial shutdown of the power system, it ensures that prolonged blackouts are avoided and stability is restored as quickly as possible. However, executing a black start is no easy feat. It requires intricate coordination and precise sequencing of operations. Imagine trying to start a car engine that has been completely disassembled. Each part must be meticulously reconnected and restarted in the correct order. That's what a black start is like, but on a much grander scale. Moreover, initiating large power plants, especially thermal and nuclear ones, can be particularly challenging. These behemoths of power generation require a significant amount of energy to restart, which can be a logistical nightmare in the midst of a blackout situation. Despite the challenges, a successful black start is a testament to the resilience of our power grid. So, to wrap it all up, let's revisit the main points. A black start, a procedure to recover from a total or partial shutdown of the power grid, is no small feat. It involves a meticulous, step-by-step process to safely and efficiently restore power. Its importance can't be overstated, as it's our safeguard against prolonged blackouts. However, it's not without its challenges, from the need for specialized equipment to the complexities of synchronization. And that, folks, is the fascinating world of black starts. Until next time, keep those lights on.